Today we start a new chapter, that is chapter number 4, which is called Chemical Bonding and Structure. And basically we are talking about the ions, valence electron. We are talking about the metal and non-metal. We also talking about the periodic table, basically, which is needed, just kind of review for this chapter.
So when you say atom, one of the characteristics of atom is how many plus it have in the nucleus, same number of minus it should have out of the nucleus. So let's say this one is 3 plus and 3 minus. So electrically this is neutral. So electrically this is neutral, no overall charge remaining, so charge is 0. And even though this is electrically neutral, but it is potentially unstable. So for atom it is more important to become potentially stable. So some atom do what they do, they lose electron to become potentially stable, and some atom they gain electron to become potentially stable. So let's say if this atom anyhow lose 1 electron, what the situation is? So here we still plus 3 charge inside the nucleus. So because he lost 1 electron, so he have 2 minus out of the nucleus. So in this situation, you see 3 plus and 2 minus. That means it have 1 excess plus. So this is no more electrically neutral. So now, because it's a 1 plus excess, so it's a plus 1. Overall charge is plus 1. In this situation, we say ions. And more specifically, you can say, because it is plus excess, we can say positive ions. And because this is plus 1, so you can also say that the plus 1 positive ions. And in other way, if this atom anyhow gain one more electron, then what will happen? In nucleus, he have still 3 plus, and out of nucleus, now he have 4 minus. He gain 1 electron. So now he have 1 more minus than plus. So this is also ions. Now because 1 minus charge is excess, so we say this is negative ions. And more specifically, you can say because 1 minus, so 1 minus negative ions. So this is the difference between atoms and ions. Whatever it is positive ions and it is negative ions. One is positive ion, that means the plus is excess, whatever it is. One is a negative ions, then we say minus is excess than the plus. In that chapter, bonding chapter, you have to remember one thing: the atom plus and minus become unbalanced, whether they gain electron or lose electron. Nothing happen in the proton. That means plus. So this is most important. So another things, one atom, they're electrically neutral, but they are potentially unstable. So for atom it is more important to become potentially stable. That's why they lose electron and sometimes they gain electron. So to become potentially stable, some atom need to lose electron and some atom need to gain electron. Okay. So now the question is, which atom can gain electron and which atom can lose electron? So who can lose electron and become positive ions? Because if you lose electron, then his plus is become excess. So who can lose electron, they are called metal. And other way, who can gain electron, after gaining electron, his minus become excess. So is called non-metal. So if you see the periodic table, this S block, this is P block, this is D block. This one have a staircase here, if you see the periodic table. So this all the atom is able to give electron or is able to lose electron. So they are called metal. So you remember, for them is possible to become positive ions. And these are the elements, any reason, they can gain electron. So they are non-metal. And because they can gain electron, so their electron become excess than the proton. So they can make negative ions, whether they can make positive ions. The atom, how many number of electron in their outermost shell? That is called their valence electron. Let's say carbon total of 6 electrons. So its first cell is 2 and second cell is 4. So this is the most outer cell because it is 4, so its valence electron is 4. Let's say sodium, its total electron is 11. So its first cell 2, second cell 8, and the last cell is 1. And it, of course, it is third. Because sodium last cell number of electron is only 1, so its valence electron is 1. This shortcut electron configuration you can do like 2n squared. So if n is 1, that is the first cell, 1 squared is 1 times 2 is 2, so first cell maximum electron number is 2. If n is 2, that is the second cell. So if you replace n by 2, the 2 squared is 4, 4 times 2 is 8. So second cell, its maximum capacity 8 because it's only 6. So remaining 4 is here, outer cell. This is, you can just shortcut electron configurations. So if you do the details electron configurations, it's like 1s, twice s, twice p. And you know S can hold 2, P can hold maximum 6, but you have 6 electrons in total, so 2 plus 2 is 4, 4 plus 2 is 6. So look at this. This is his most outer cell, and his most outer cell, number of electrons 2 is 4, and he have two kind of orbits, one is S, one is P. So in case of sodium, 1s, twice S, twice P, thrice S. 2, 2, 6, 1 is total 11. So you can see in case of sodium, this is the most outer cell, number 3. This is the second cell, number 2, and this is the first cell, and number is 1. So in sodium, we have one kind of orbits, that is S, in the outermost cell, and only one electron, valence electron, so far we call. So if you see the periodic table roughly, this is the structure of the periodic table, and here is, you can say, lithium, sodium, potassium, rubium, CS, and Fr, and here we can put the fluorine, chlorine, bromine, iodine, then At. So this is the roughly the periodic table. So now this is the S block, and this is called P block, and this is called D block. The reason we call this, because if you do the electron configuration, the outermost cell have S, most outer cell have S, and if you do their electron configuration, their most outer cell have P, and if you do their electron configuration, you can see their most outer cell have D orbits. So that's why this is called S, P, D. If you see my periodic table lecture, you can know more details about that. But now we're just talking about which is needed So kind of revision which is needed for the bonding chapter. You can see this is group number 18, 17, 16, 15, 14, 13, and this is 1 and 2, and this is called transitional element. So group number 18, they are called noble gas. Helium in top, then we have neon, then we have argon, then we have krypton, hexon, radon. So these are the group number 18, and these are the atoms. They don't like to give electron, they don't like to gain electron, because whatever they have, it is already potentially very stable. And these all other is non-metal, they can gain electron, and this metal they can lose electron. Now talk their oxidation number. This oxidation number is 0, -1, -2, -3, -4, and this oxidation number is 1, 2, and 3. This means all the elements here, they can gain 1 electron. All the elements here, they can get 2 electron. Here they can gain 3 electron. In other way, if you talk about the metal, all the atom here in these groups, they can lose 1 electron. Here they can lose 2 electrons. So if you see sodium loss 1 electron, become +1, potassium loss 1 electron, become +1. In other way, if fluorine gain 1 electron, he become F-, chlorine gain 1 electron, F-, bromine gain electron, F-. So how do you know from the periodic table that how many valence electron they have? So if you see the group number 18, they have 8 electron in their outermost shell. Group number 17, they have 7 electron in their outermost shell. Group number 16, they have 6 electron in the outermost shell, and so on. Group number 1, that means they have 1 electron in their outermost shell. Group number 2, they have 2 electron in their outermost shell. And group number 3, group number 4, group number 5, so on. That means they have 3 electron in their outermost shell, 4 electron in the outermost shell, 5 electron in the outermost shell. So that's in shortcut we can know how many valence electron atom have. So these are all called transitional element, that is D block. And somehow their electron configuration is like that. They can give sometime 1 electron, they can give sometime 2 electron, they can give sometime 3 electron. Like this, like say copper can give 1 electron, can become copper plus, can give 3 electron, can become copper 3 plus. Sn can give 4 electron, Sn also can give 2 electron, both is potentially stable. This one we'll discuss in more details why they can do like that. So this is roughly we need to know about the